Hopefully this will be the last part, so let's get rocking and rolling. It says, if g of x equals 3x squared plus 2x minus 1, find g of 3 minus I. So really it's saying take 3 minus I, put it here, and put it here. Now remember, I squared equals negative 1. I is actually the square root of a negative 1, but with that in mind, let's attack. So it's 3 times 3 minus I squared plus 2 times 3 minus I minus 1. This right here, we got to spend a little time foiling it out. So that'd be 9 outside inside minus 6I, and then this is plus I squared. Remember what I squared is, it's negative 1. So I've got 9 minus 6I minus 1. Now I'm going to distribute that, plus 6 minus 2I minus 1. Now I just go looking for like terms. So 9 minus 1 is 8, plus 6 is 14, minus 1 is 13. And then negative 6I minus 2I is negative 8I. You would be done. Okay, this one. Solve. Common bases, happy places. I see the 3 and the 27. I'm going to make that 27 3 cubed, and I'm going to bring it up. Now, this stays. So 3 to the 2x minus 1 equals, now watch this, if I bring a positive exponent up, it becomes negative, and then this 3 just comes along for the ride right here. Now I have a power to a power situation, so 3 to the 2x minus 1 equals 3 to the negative 9. These cancel, so I end up with 2x minus 1 equals negative 9, add 1, I get 2x is negative 8, divide by 2, I get x is negative 4. Done. Alright, this one, common bases, happy places, not happening. So this is where we need to slap a log on. So log of 2.8 to the x power equals log of 47.5. Now remember what we can do when we have a logarithm, we can put that in the front. So it's x times, now I'm going to take my calculator and figure this stuff out, but I'm going to hit pause here. Alright, so I looked up log of 2.8, gives me this, log of this, gives me this, round it a little bit. Now I got to divide by 0.447, divide by 0.447, which I've already done on my calculator, and I get x is 3.75. So there's A. B, little different thing going on here. I'm going to divide this by 3 to get rid of that, divide by 3 to get rid of that, and I get 5 to the x equals 5. Now look at this, there's an invisible 1 there. So x is 1. Just has to be. Common bases, happy places. Now we've got this situation where, okay, so we've got a log over here, we've got a log over here. Let me get a new piece of paper. Okay, under further investigation, this problem doesn't turn out to be that bad. Don't need another piece of paper. We are on the hunt for the natural log of e, because that equals 1. So if we combine two rules, the fact that natural log of e is 1 and that we can bring that in the front, this is a simple way of saying 2, because it's really 2 times 1 plus 3 equals 2 times the natural log of x. Now, over here, I'm going to put it here. Why? Watch what happens. What's 2 plus 3? I'm going to flip this thing around. I get the natural log of x squared equals 5. Now, why does that help me? There's an invisible e here. So I can go, aha, e to the 5th equals x squared. So what I'm going to do with this is I'm going to take e to the 5th equaling x squared, and I know that I have to find out what e to the 5th power is. So I'm going to take my handy dandy calculator, and I'm going to go 2.71, because that's what e is, to the 5th power, and I get 146, we'll call it 0.2. So 146.2 equals x squared. So we go bada boom, bada bing, do the right thing, And we got to take the square root of that. So second square root 146.2, 12.09. So we get x is plus or minus 12.09. But remember, we can't have a negative number in here. It just doesn't work in the world of logarithms. So we can get rid of the negative 12.09. So it's only 12.09. And there we go. Almost done. Okay, number 42. First thing we need to understand is, in order to graph this, we need to know the parent function y equals log of x. What does it look like? Well, remember, our locator point for this is 1, 0, because if we looked at this the way we should, 10 to the 0 power, that's my y, equals 1, that's my x. So 1, 0 is always my locator point, but then it kind of goes like this, and that's the asymptote right there. Because remember, we can't have any negative x's. Doesn't work. So we have to make an adjustment. What does this do? Left 2, down 2. So I'm going to take my locator point. Well, actually what I should do, I know that this is my asymptote for the original. If I have to go left 2, that means the asymptote must also get moved left 2. Then this gets moved left 2, and then I just duplicate it, like so. But I'm not done yet, because now, for the grand finale, we'll go pink, have to go down 2. So that locator point, which is very helpful, is there. And then it's just going to be like that, ish. So there. We got real close. All right, now we got an exponential function here. So, what's our locator point for an exponential function? Well, to get started, we're going to let x equal 0. 2 to the 0 power would be 1. 1 times 4 is 4. So 1, 2, 3, 4. There's our locator point. And if you recall, if this number is greater than 1, it's going to be exponential growth. So we know it's going to look something like this. And that's all we got to kind of focus on. So example 43. Using this formula, determine how many years, remember years is time, so we're going to have to use logarithms to get that out of the exponent. How many years will it take to quadruple your money? Now notice they didn't give us any money amount. So really, we could just think of, okay, if we invest $1, you could use 10, 20, you could use anything you want. But that's our initial investment. I'm going to use 1. But to quadruple our money, that means we'd have to have $4 over some time. E, that's 2.71. My interest rate is 6.3%, so that's 0.063 changed into a decimal times t. Now, this is the same thing as 4 equals e to the 0.063 t power. Because my base is an e, I'm going to slap natural logs on both sides. Remember, because natural log of e is 1. So I'm going to figure out what this is. And I'm going to go natural log of 4 is 1.386. 1.386 equals, remember, we can bring this into the front of this. And what's this? 1. So that's 0.063t. Now I got to divide both sides by this. 0.063. And so here we go, divided by 0.063. 22.0004. So approximately 22 years to quadruple my money. Now that'd be worth it if I invested $1 million. I have 4 million. Okay, number 44, sketch this graph. Well, here's one of my zeros, 2. Here's another 0, -1. And another 0 is a 0, 0. Now, I can look at this, and I can see that this is an even function. I got a 2 and a 2 and a 2. That means, and my a is positive. There's no negatives in front of this. And also, I'm squaring everything. So a has to be positive, which means my outer extremities are going to go like this. So I'm going to go like this. and I'm going to go like this. Also, we know, because this is even, 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 they're going to bounce off these. So I need to know how high this goes, and I need to know how low this goes. So we got to figure out approximately, that's negative 1/2, so we got to let x equal negative 1/2 and figure out how high this goes. And I guess it bounces, so it's going to, anyways, let's just do the math. And we're going to let x equal 1 because that's the halfway point between these 2 points. Now I'm going to do the math and then show it to you. So again, that point between 0 and negative 1 is negative 1/2. So I plugged it in here, here, and here into the original, and I got 0.76, which means it barely goes up and comes down. Now originally I said it goes under. That can't be true because it doesn't go through here. It bounces off, so it's going to go up. Did the math. I put a 1 in here, here, and here. Crunched it all out, and I got 4. So this, 1, 2, 3, 4 is here. And there we go. Perfect? No. Does it get the job done? Yes. Okay. Just so you know, the exam review is a lot longer and more inclusive, bigger range than the actual exam. So if you're thinking, I'm never going to finish the exam, relax a little, because this is a big time sucker upper. So it says, write a 4th degree polynomial function with roots plus or minus 2 plus I, x is 1, x is 3, passing through 1, negative 2. This problem takes a while. I'm going to start with this and this because I think it gets the ball rolling. We know that if this is one of our solutions, that we just think backwards, and it has to look like this, and it has to look like this. Notice we are subtracting our actual root. Now we've got 2 plus I as a root, and we have plus or minus. That's written very poorly. Hold on. There, that cleaned it up a little. But we got minus 2 plus I, which would be negative 2 minus I, as the other root. Now, go back to here. We subtracted our root. We subtracted our root. This is where it gets a little dicey. How do we subtract this? We got to go x minus 2 plus I. And then for this one, we got to go x minus negative 2 minus I. Well, I'm going to start with this, FOIL it out, x squared minus 4x plus 3. That's the easy one. Now this gets crazy. So we're going to clean this up. X plus 2 plus I times x, we've got to distribute, minus 2 minus I. So this is a 3 thing times a 3 thing. So this is where I like my 3 by 3 box. So x, 2, and I, x, negative 2, negative I, x squared, 2x, ix, negative 2x, negative 4, negative 2I, negative ix, negative 2I, and this is a negative I squared, which is actually a negative 1, which is 1. Notice these cancel. These cancel, and what I end up with here is, give me a second. Okay, this is what I get for writing my own exam review. Remember I thought, hey, this is written funny? So yeah, it's supposed to be 2 plus or minus I instead of that. Now to save you some time, nothing changes here. So this goes to here, which goes to here. That didn't change. But then, when I have 2 plus I, and I subtract it, and I have 2 minus I, and I subtract it, I get this and this. Plug it into here, and this is what I get. And this is what was supposed to happen. So the IX's cancel, the 2I and the negative 2I cancel, and you see that didn't happen in this one. I would have gotten negative 4I, and that would have been a nightmare. So, if we clean all of this up, it ends up being x squared minus 4x, and then 4 and negative 1 is 3. But we still need to multiply that Oh, how bizarre is this? It's the same thing. Negative 4x plus 3. What are the odds of this? So now we got to do the same thing to this. That's why I'm saying this is like a very long problem. So I get x squared minus 4x plus 3. I've never seen this happen. I don't know what the odds are. Negative 4x and 3. So we get x to the fourth minus 4x cubed, 3x squared, negative 4x cubed, 16x squared, negative 12x, 3x squared, negative 12x, 9. Now, this is, so y equals x to the fourth, done with that, minus 8x cubed, these two. Then we go down the list here, 16, 19, 22, x squared, minus 24x, plus 9. Now, here's the problem. We need to know what a is. We need to know what the leading coefficient is. It says it passes through 1, negative 2. So we got to put a negative 2 in for y. We got to put a 1 in for x. I'm going to pull the plug on this problem. I know you're going to think I'm crazy, but I'm going to take this out of the instructions and we're good. There, I just did that. All right, that finishes this video.